Okay, this is Unit 5, 5.4. These are the sum and difference formulas. We're going to write these out. It is not necessary to memorize these. You will be given these on a test. However, it is very important that you know how to use them and what it means when you write them out. Okay, so we're going to start off with the sum and difference. The U and the V are both angles. So these right here, the U and the V, are both angles. And so what we're doing is we're adding angles together, or we're subtracting angles. And the formula for this is, if it's sine, you would write sine of the first angle, cosine of the second angle, and then you would have the same sign. Sine has the same sign. So if it had a plus between it, it would have a plus between it here. And if it had a minus, it would have a minus. And then you just repeat it on the other side. So I would say sine V and then cosine of U. And so you'll notice that the sum and difference formula for sine, it has both a sine and a cosine in it, and it has it on either side of the plus sign. So it's multiplied, multiplied, this is plus or minus. Now for cosine, cosine is the same thing, cosine, except that it has cosine of the first, cosine V, and then it has the opposite sign. Right? So if this is a plus, then this will be a minus, and if it starts out minus, it will be a plus, and then you just have the sign of the angles on the other side. So sine U, sine V on the other side. Okay, tangent is a little more complicated. This is why you're going to be really glad that you have these and you don't have to memorize them. But on the numerator, we have tangent U, sorry about that, tangent U and tangent V, and then the sign in between them is the same sign on the top. On the bottom you have a 1, and then you have tangent U times tangent V, and then the sign between them is the opposite, so there'll be just the opposite sign of what you have there. So these are your sum and difference formulas. Okay, the question here is, are they the same? And I don't have the degree symbols written on here, but these are just degrees. It's 150 degrees and 0 degrees. All right, so what we're going to do is we're going to use the cosine formula to write this out, and then we're going to see if it matches up with the cosine of 150 and the cosine of 0. So here, remember, cosine is cosine of the first, cosine of the second, and then the cosine is the opposite sign, so since that's minus, this will be plus, and then I will have the sine of 150 and the sine of 0. Okay, and since those are all values off the unit circle, cosine of 150 is 5 pi over 6, if that helps at all. So the cosine is negative in that quadrant, so it'll be negative cosine of 5 pi over 6 is square root of 3 over 2. The cosine of 0 is 1. And then plus the sine at 150 is 1/2, and the sign here is 0. So the answer would be negative square root of 3 over 2. Okay. Over here, if I just take the cosine of 150, that would be the negative square root of 3 over 2 plus the cosine of 0, which is 1, which is definitely not equal to the negative square root of 3 over 2. So what that leads us to say is that the cosine of 150 minus 0 is not equal to the cosine of 150. You have to use the formula. That's what this means. You have to use the formula to write it out. So this part up here is valid, this part down here is not. It does not get you the same thing. By the same token, we can do the same thing here with the cosine using radians. All right, so are they the same? So I'm going to write this out using the sum formula. So cosine is cosine of pi over 2, cosine of pi over 4. Cosine is an opposite sign, so that's a minus. The sine of pi over 2 and the sine of pi over 4. All right, well, I know the cosine and the sine of pi over 4 is square root of 2 over 2. And all of these seem to be either quadrantals or in the first quadrant, so that makes me happy. The point at pi over 2 is at 0, 1, right? So the cosine is going to be 0, and the sine is going to be 1. So this is going to be negative square root of 2 over 2. So the sum of these two angles, is going to be the negative square root of 2 over 2. All right, so then if you go down to the bottom and you say, what is the cosine of pi over 2? Well, that's 0. And the cosine of that is square root of 2 over 2. And these do not equal each other. So I have square root of 2 over 2. So square root of 2 over 2 does not equal negative square root of 2 over 2. So that means that you cannot say the cosine of pi over 2 plus pi over 4 does not equal the cosine of pi over 2 plus the cosine of pi over 4. Okay, so one of the problems will look like this. They will give you an angle. Theta is 165 degrees. Well, 165 degrees is not on the unit circle. So what they want to do, I don't have a calculator, but I do know that if I take some angles that are already on the unit circle and maybe subtract or add, for instance, theta, if I let 225 degrees minus 60 degrees, well, 225 degrees minus 60 degrees is 165 degrees. So it says I'm going to use that subtraction to put that together. So I'm going to use the sine. I'm going to find the sine of 225 degrees minus 60 degrees. I'm going to find the cosine and then also the tangent. So I'm going to go ahead and write this out. This would be the sine of 225, the cosine of 60, and then it's the same sign, and then I do the sine of 60 and the cosine of 225. 225 is 5 pi over 4. Cosine is 60. 60 is pi over 3. So that's what I'm dealing with here. So the sine in the third quadrant is negative, and the cosine of 225 is also negative. So that helps a little. And then the cosine of pi over 3 is 1/2, and the sine is square root of 3 over 2. And then I have a minus between them. So I have the sine of 225 is square root of 2 over 2. This is square root of 2 over 2. So this is going to be negative square root of 2 plus square root of 6 all over 2 times 2 is 4, and that's your answer. Okay, we'll do this with cosine. So cosine of 225 minus 60 would equal the cosine of 225 times the cosine of 60. It's the opposite sign. And then I would have the sine of 60 cosine of 220, sine, cosine, sine, oops, this should be a sine, sorry, I couldn't figure out what I was doing. There we go. So this is the sine, right, of 225. Okay, so the cosine, since I've already done this up here, the cosine of 225 is square root of 2 over 2 negative. The cosine of 60 is 1/2, no need to reinvent the wheel there, plus the sine of 60 is square root of 3 over 2, and the sine of 225 is negative square root of 2 over 2. And so if I multiply all that together, I get negative square root of 2 minus square root of 6 all over 4. Okay? And then just leave it like that. That's your exact answer. So your last one then is to do the tangent of 225 minus 60 degrees. All right, so the tangent would be the tangent of 225 minus the tangent of 60 all over 1 plus tangent 225 tangent 60. Okay, and you're going to write your answer in the exact form. So the tangent of 225 is just 1 minus the tangent of 60. 60 is pi over 3, so that'll be square root of 3. And then I've got 1 plus the tangent of 225 is 1 times the tangent of 60. So that would be this. Now, the back of the book is not going to have that answer. The back of the book is going to have an answer that's been rationalized, but this is sufficient for an answer. So these three answers right here would be what you would get for this type of problem. And that's using the degrees. I think the toughest part about this exercise is trying to find two angles off the unit circle that will actually add to the one that you want. So for instance, if you had theta is equal to 13 pi over 12, right? We don't have any pi over 12s on the whole unit circle. We have pi over 3s and pi over 6s, right? So if we listed 0, pi over 6, pi over 4, pi over 3, pi over 2, and then move into the second quadrant, so you have 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi, and then you converted all of those to twelfths, right? You'd still have 0, and then you would have 2 twelfths, which is pi over 6, and then you'd have 3 twelfths, and then 4 twelfths, and then 6 twelfths, and then you'd have 8 twelfths. Yeah, that's a half, and then 4 2/3, yeah. And then this one would be 9 twelfths. Can't write that. And then 5 would be 10 twelfths. And then pi is just 12 twelfths, right? So now that you've got that written out, you can see clearly that there are two of these that could add up to 2 of these twelfths, right? So I could have, that would add up to 13. So I would have, 3 pi over 12 plus 10 pi over 12, right? Those two would add up to 13 pi over 12. So that's not what you would call it, though. You would say either the cosine or the sine of, you would go back to their originals. So 3 pi over 12 was 4 pi over 4 plus 10 pi over 12 would be 5 pi over 6. So that would be your angle that you would add together, and it would be an add because 3 pi over 12, which is pi over 4, and 5 pi over 6 added together would get you 13 pi over 12. So you'll have to be a little clever when you do stuff like that, but that is exactly what you do. There would also be another one that you could do. You could do 4 pi over 12, 4 pi over 12, 4 pi over 12 plus 9 pi over 12. So can you see that? So having this written out is kind of handy, because then you can kind of look up if you need them in twelfths, or if you need them in sixths, or whatever you need to do. You can find angles that would add together to get the angle that you wanted. 4 pi over 12 is pi over 3 plus 9 pi over 12, which is 3 pi over 4. So you could have the same thing, and you could do either one. You could also do subtraction on some of these, not on this particular one, but you could do subtraction to find the angle that you need. Now, just as they're taken apart, you can also use the formulas, the sum and difference formulas, to put them back together again. And so you can see here that you've got cosine of 60, cosine of 20. So if it's cosine, we know it's going to be a cosine of two angles. So 60 and 20. We know that cosine is the opposite sign, so since that's minus, this is going to be a plus between them. So this really is the same thing as cosine of 80 degrees. These are all degrees. Okay, so that's all you're doing, is you're just putting them back together again. This is an identity, proving an identity problem. So this is one where we're going to verify an identity. That's what we called it in the last section. Verify an identity. Okay, so what we have here is something that looks very similar to the cofunction, right? except that it's pi over 2 plus x. So I'm going to write this. This is a sum formula. So I'm going to write the sine of the first angle times the cosine of the second. The sine is the same sign, so plus the cosine of pi over 2 and then the sine of x. All right? And at pi over 2, remember that the point is over 0 up 1. Sometimes it's helpful if you just write out the point. Okay? So this is cosine, this is sine. So the sine is going to be 1 times cosine x plus 0 times sine x. Anything times 0 is just 0. So we have cosine x is equal to cosine x, and it has been proven. All right, so we have verified that that is equal. It looks like the cofunction too, doesn't it? Add the angle to it, you got it. Okay, write these 4 problems down. You're going to find 2 angles from the unit circle that you could add or subtract to get the angles given. You don't have to find the sine, the cosine, and the tangent. You just have to find 2 angles that when you add them together off the unit circle, you will get these values. All right, have those ready in your composition notebook, and I will see you in class.